Year 5 and welcome to this week's science. I hope you're having a good week so far, and I hope you're looking forward to being back in school on Monday, because we are really looking forward to seeing you all. So today we are going to be learning about what a physical change is and how we can identify them. So this is going to involve our solids, liquids and gases that we've been learning about most of the year. But obviously last week you looked at changes of states with Mr. Walker, and that's going to come into today's lesson. And we are going to do some total recall about those states to start off with, just to help us refresh our memories, and hopefully that knowledge will then help us understand what we're going to learn today. So can you pause the video to start your first bit of total recall? Can you just remind yourselves how each of the states of matter are represented in a diagram as particles? And then at the bottom complete the missing words, as in what the correlation between temperature and how the particles move are. So that's having a think about what Mr. Walker said last week. What happens to the temperature? What do the particles then have maybe more or less of? So see if you can remember. Pause the video, quickly draw that and write that out into your books. Okay, let's have a look at the answers. Grab a purple pen and tick and fix anything that is right or wrong. So our solids particles are all touching in straight lines. There shouldn't be any gaps between any of the particles except right in those little middle parts. Liquid are still touching but more spread out, can move a bit more freely. And gas are completely untouching, moving about. And then our missing words, it's when we increase the temperature of our particles have more energy. Okay, and that's really important to remember for our change of states. So obviously when we decrease the temperature, the particles have less energy. Okay, next piece of total recall. Pause the video again. Can you answer these? So for a solid, can it be compressed? Think of the bottle example that Mr. Walker did last week. Can a solid flow, and can a solid change shape? Can a liquid be compressed? Can it flow? Can it change shape? There's a bigger box here, so it might be a more detailed answer. And gas, can a gas be compressed? Can it flow? And can it change shape? Okay, get your purple pen ready to tick and fix any of your answers. So let's have a look at solid first. Can a solid be compressed? No. Okay, a solid is solid, so you cannot compress it in any way. Can it flow? No. A solid is, if you think of the particles, those particles do not move, so a solid cannot flow. Can a solid change shape? No. Those particles are so secure that you cannot change the shape of a solid item. On to liquid then. Can a liquid be compressed? Think of Mr. Walker having that bottle of water last week. Could he compress it? No, he couldn't. Okay, because liquid fills the shape. Okay, and it can't move around once it's filled completely that shape. It cannot be compressed. But can liquid flow? Yes, it can flow. Okay, the particles are a bit more free moving, so those particles can flow more than a solid. Can a liquid change shape? So like I just said, yes, but it takes the shape of the bottom of a container that it's in. So if it's in a bottle or a cup or a mug, it will take the shape of whatever container it is in. And finally, a gas. Can it be compressed? Yes. Can a gas flow? Yes. Those particles are really spread out, so they're moving and flowing about all over the place. Can a gas change shape? Again, it fills its container. Okay, so just like when Mr. Walker had the empty bottle last week, he was able to compress the bottle. The gas would have been flowing around in the bottle, but the gas also filled that bottle up, even though you couldn't see it. So well done if you got any or most of those right. Last piece of total recall then. are 4 key words of state change. So what does each arrow represent on this picture? If you can just briefly write them into your book. So just do solid, arrow, liquid, write when a solid becomes a liquid, what do we call it? What do we call it when a liquid becomes a gas? So here our heat is increasing. What then happens when the gas is cooled and hits a cold surface and becomes a liquid? And then what is it called when a liquid is cooled and becomes a solid? And once more, grab your purple pen so we can tick and fix. So a solid turn into a liquid. If we think about this ice, and last week the solid to a liquid is called melting. That liquid then, if we continued to heat it, it became steam, so that was boiling, if you think when you boil the kettle for your cup of tea. But then when that hot gas hits that cold surface, so it's cooling again, it becomes a liquid, and that's called condensing. So if you think of condensation on your window sometimes in the morning, that's because your body heat has gone off in the air during the night, so the gas particles in the air are quite hot, and it's hitting your cold window because it's cold outside, so then it creates the water on your window, condensation. And then finally that liquid is continued to cool even further, becoming a solid, and we call that freezing. So well done if you got those. On to today's lesson then. So over the next couple of weeks we're going to be learning about chemical and physical changes. So just briefly over a chemical change. A chemical change is a chemical reaction which forms a new product. So things like combustion, rotting, rusting, digestion. They all form a new substance. Whereas a physical change is a matter that changes form but not chemical identity. So paper, shredding paper, you can have paper as a whole. When you shred paper, it's still paper, okay? Or chopping wood, you can have a big piece of wood, chop it into smaller pieces of wood, it's still wood. So a physical change is when something just changes in physicality. It's the change in the form or arrangement of a substance, and this is what we're going to be focusing on today. Next week you'll learn more about a chemical change. So some examples of physical changes are ice cream melting. So if you think that's going from a solid to a liquid, isn't it? Paper tearing, like I just said, a bit like shredding or even just ripping a piece of paper. When we rip it, it's still paper, it's just changed its form. And glass smashing. Okay, we can have one big pane of glass, or we can have tiny little bits of glass, but it's still glass. It hasn't changed what it actually is. So the form or arrangement of these items have changed, but the type of particle has stayed the same. Okay, this is still a water particle inside. This is still paper particles, and this is still glass particles. Okay, the particles haven't changed, just the way it looks has changed. So let's look at another example. What happens when I tear a piece of paper? So we're going to look at this in a bit more depth. Is it still paper? Yes, the particles are still paper particles. What happens to the arrangement? The arrangement and form has changed. We have smaller pieces of paper rather than one large piece of paper. So the form and arrangement of the subject has changed, but the substance itself has stayed the same. So this is just a physical change. Again, if we think about the ice or the water, what happens when I put water in the freezer? Is it still water? Yes, the particles are still water particles, but the arrangement and the form has changed. The water particles have changed from a liquid to a solid. Okay, so the paper was still a solid, but it still looked different when we ripped it up, whereas the water has changed state from a liquid to a solid, so it looks different, but the particles are still the same. So just pause the video for a second and write can you write 3 examples of physical changes in your book? So we just looked at about 4 there. So can you write 3 examples into your book? And welcome back. So just to finally recap and remind us, if you think of physical change, so if you think of humans, okay, your physical looks, that's what you look like, okay? So physical, if you think of physical as the way something looks, and we're thinking about physical changes, so it's the change of how something looks, and that can be including it changing in its state of matter. So the form of the substance has changed, but it is still the same substance with the same particles. It's not creating something brand new. So thinking of that, you don't have to put these in your books, you can if you want to. I just want you to pause and think about these for a minute or so. And I want you to decide whether these things are a physical change or not. I want you to think, what particles are present at the start? Are they liquid particles? Are they solid particles? Are they gas particles? What are present at the end when the change has happened? And has the arrangement of the particles changed? Is it going to be a physical change or not? So, water boiling in a saucepan. What particles are present at the start? What particles are present at the end? And has the arrangement of the particles changed? So, before we boil the water, what do we put into the pan? We put water in, which is a liquid. So we have water particles. Okay? What particles are present at the end? Well, a bit like Mr. Walker said last week, it becomes a gas when we heat it, but it's still water particles. Okay? They've just boiled. Okay, so has the arrangement of the particles changed? Yes, it has changed from a liquid to a gas. They are still the same particles, but the arrangement of the particles has changed. But because they are the same particles, and we have done boiling, this is a physical change. So well done if you got that one correct, because it's still water. How about this one then? Ice melting in my drink. What particles are present at the start? What particles are present at the end? Has the arrangement changed? So, very similar to the last one. Ice is water particles. When it melts, it becomes a liquid, which is still water particles. So the particles have stayed the same again, but the arrangement has changed from a solid to a liquid. So we've changed from our solid particles, we've heated it up so it becomes a liquid, so this process is melting. This is a physical change because the particles are the same, just the arrangement is different. Okay, think about this one then. Is this a physical change? A bonfire burning. So what do we start with before we add fire to a bonfire? What helps us create a bonfire? But then when we finish a bonfire, at the end, what particles are present? What are left at the end? Has the arrangement of the particles changed? Okay, so what particles are present at the start? We have wood. Okay, we need the wood to create the bonfire. What particles are present at the end then? Do we still have wood particles left after a bonfire? No, we don't. We have ash. Okay, so in this case our particles are different. So what are you starting to think? Is this a physical change or not? Has the arrangement of the particles changed? No. It has created a different substance rather than a different form of the same substance. So whereas before we still had water substance, but it was just either a gas, a liquid or a solid, this time we've got a completely different substance altogether. So this is actually a chemical change, because wood is a solid and ash is a solid. Okay, but it's a completely different substance. So this is more what you're going to do next week, chemical change. Finally, here's another one just to quickly think about. This is quite a difficult one. So just have a quick think. So salt dissolving in water. So what particles are present at the start? So we have both salt and water, okay, but separate. Once we've mixed them together, what particles do we have? Well, we still have salt and water. They're just mixed together, and if you remember back just before half term, your science lesson with Mrs. Lee, has the arrangement of the particles changed? Yes, it's gone from a solid and a liquid, so the salt and the water, to a solution. Okay, so we've still got salt and water at the end, it's just in a different form. Okay, it's become a solution, it's dissolved and mixed together. Right, we are going to investigate today what happens when chocolate is heated up. So you are going to need a cube of chocolate. Just one cube will do. You can use more if you want to, but one will be enough if you would like to eat the rest. And then you either need a hot lamp, and it needs to be a lamp that gets quite hot, a candle, but you need an adult if you are going to use a candle. The easiest option might just be to use your pan and stove, or your pan and your hob. Okay, so if you go and make sure that you've got all those things ready, and then I am going to model this using a candle, which I just need to be very careful with. There we go. Okay, my lamp doesn't get very hot at all because of the bulb I've got in it, so my easiest option here is to use a candle. So I have my candle in a jar, so it's sat, you can't read, my camera's at an awkward angle. My candle is sat in my glass jar. Okay, I then have a cube of chocolate in a small bowl. We are going to time for 3 minutes. Okay, what is going to happen to our cube of chocolate when we put it over heat? So you're either going to put it under your lamp and where it's providing heat, you're either going to put it over your candle, or you're going to put it in your pan and turn your hob on so that it's heating up your pan and your chocolate. Okay, so I'm going to start the timer. We are going to time it for 3 minutes and just see what happens over those 3 minutes to our cube of chocolate. Now, I'm not going to put this directly on top of my candle. I am going to leave a gap, but you just won't be able to see. Okay? Oh, my battery's going. Right. Let's start our 3 minutes then. Okay, I'm just going to see if I can really focus this. That's probably the best it's going to get. Yeah, that's the best it's going to do. So 3 minutes. When I get halfway, a minute and a half, I might just need to touch the chocolate a little bit to hopefully show you what's happening. So I've got this over my candle. So my candle is giving off heat. Hopefully your lamp is giving off enough heat, or your hob should definitely be giving off enough heat. Just make sure you've got an adult. Okay, nearly a minute. Now it's not looking like much is changing, although I've just noticed a little bubble has come up on that side. Okay, let me tilt that a little bit. So from the top, it doesn't look like much is happening at the minute. I'm just going to wait 20 more seconds and then I'll give it a little push and see what's happening, if anything is happening underneath, because obviously the heat is getting the bottom of the chocolate first. Okay, we're halfway, so I'm just going to move it a little bit. Okay. So what is starting to happen to our chocolate? Obviously you've probably already know and predicted what was going to happen, because Obviously this happens to chocolate quite a lot. But what is the process that you learnt last week? What is happening here? So our chocolate started as a solid, and it's now being heated. Those particles are getting heated and they're gaining more energy, and it is now becoming a liquid. So what is that process? It's called melting. And obviously it's just like when it's a hot summer's day and you take an ice pole outside or a chocolate bar, because the sun is so hot and we've got high temperatures, that's why everything melts, because those particles are gaining more energy. Okay, 30 more seconds. Just give it another little push. So that's really getting a lot of energy. It's really melting now. 10 more seconds. Let's try and focus it again. Is it focusing? So that's our 3 minutes over. So as you can see now, it doesn't want to focus. Let me try one more time. There we go. Okay, so now there's still a little bit of solid on the top, because the heat didn't quite get through to the top part, but it has mostly now changed from a solid to a liquid. Those solid particles have been heated up by the candle. Okay, I'm just going to blow that out actually, before I burn my hand. Okay, so they've been heated up by the heat. They've been heated up by the heat. They've been heated up by the candle, so the solid particles gained more energy, and we know that when a solid particle heats up, increases in temperature, it melts and it becomes a liquid. Okay, so hopefully if you've joined in, you've managed to get the same results as well. If you've used a lamp and it's not quite melted yet, keep going. You can do it for a bit longer, see if it should work eventually. Okay, but if it's not working with a lamp, it might be best to go and put it on your hob and a pan with an adult. Right, let's go back to our slides. So your method there was putting your square in a plate or a bowl, putting your lamp on or putting your candle on underneath, and watching what happened to the chocolate for 3 minutes. So I would like you to pause the video here and complete this diagram in your books. So what would have the solid particles look like at the beginning? So how do we draw solid particles? What did it then look like when it had heated and melted? So what do the liquid particles, how do we draw them? And then what are these key words again? What happened to the temperature and the particles gained what? I kept saying it. The particles have a little clue. Okay, so pause the video and complete that. Once you've then completed that, could you then answer these conclusion questions in your book? What happened to the chocolate when you placed it under the lamp? So go into detail about what was happening to the chocolate, what was changing, what was happening, what did it become? What happened to the energy of the particles during this process? So you should have just written that one in your book with the last question. So the energy was what? Draw a particle diagram to represent the particles at the end of the investigation. So it had changed to a liquid, so what do the particles look like? Is this a physical change? Yes or no? How do you know? Explain why this is a physical change. So think carefully about how we talked about physical change is it has the same particles, it's the same substance, it just looks a different form or arrangement. Okay, so explain why this chocolate is or isn't a physical change, this melting of chocolate. Okay, and once you've completed them, we can tick and fix those. So a solid's A solid particle looks like this, a liquid particle is a bit more free, and it was the increase in temperature means particles have more energy. And then finally, the chocolate melted when it was placed under the lamp, so it started as a solid and became a liquid. During the melting process, the chocolate particles gained energy. This is what it looked like at the end, as liquid particles. Yes, this is a physical change, because the chocolate melting, chocolate melting is a physical change because the arrangement of particles changes. Okay, the arrangement of the particles changed. They changed from a solid to a liquid, but it was still chocolate. Okay, and it was just melted chocolate. So well done if you got all of those right, Year 5. Well done on today's lesson, and you can now enjoy the rest of your chocolate bar if you have any left. I'm going to go enjoy mine. Talk to you later. Bye.